Okay, and 5.4 continued, more application exercises, more word problems. Page 2 of the notes here. We're going to keep using these same steps, so I've reprinted them on each page for you. And let's look at number 28. And again, there's some instructions up above that are always good to note. As you look at a problem, if it's not making sense to you, scroll your eyes back up to see if there's some additional information that covers a block of problems. In this case, it says, in exercises 27 and 28, an isosceles triangle in which angles B and C have the same measure is shown. And by the way, that is the definition of an isosceles triangle. You have two measures of angles that are the same. Find the measure of each angle whose degree measure is represented with variables. So we read it once, we take a deep breath, read it again, preferably out loud both times if the space you're in allows for that. And let's see what we can find out in terms of what they're giving us, a picture maybe, highlighting that we could do for key information, and then what is the goal that we're trying to find. So an isosceles triangle in which angles B and C have the same measure is shown. So that's what these little markings mean, is these are the angle measures that they're talking about. So angle B is equal to angle C, is what they've given us so far. And then we're going to find the measure of each angle whose degree measure is represented with variables, which is a fancy way of saying they've got equations for all of these. So they have 10x plus 10 represents your amount for C, 9y minus 2 represents your amount for B, and A up here is 4x plus 2y. That represents your angle for A. So let's look at what the goal here is, and then we'll see if we need to bring some information to this, bring your own formula. So our goal in this situation is to find the measure of each angle. So our final result here, our goal, is to come up with what angle A equals, and these will be in degrees, angle B, and angle C. Okay? But before we can come up with that, we're going to have to find the x and y values. So the algebra is going to take us to a value for x and a value for y. But then we have to accomplish the goal of the question, which is to come up with our answers for A, B, and C. So first we'll come up with what x equals and y equals, and then we'll accomplish our goal of plugging those back into each equation and getting our A, B, and C value. So in this case for A, we're going to plug it back into 4x plus 2y. Our B value, we're going to plug back into 9y minus 2, and our C value, we'll plug our x's and y's back into 10x plus 10. So we find our x and y, we're going to plug them into here, and that'll give us our final answers. Let's look at what we need to set up now. And now that we've really looked at what our goal is, where we're headed, let's see what we need to bring to the problem. And even though the picture is drawn for us, some of us might really benefit from maybe even redrawing the picture on our own paper since it's in the book, just to get a feel for what really is happening here. There's just something that unlocks it when you take the time to draw it yourself. You notice they have these little tick marks on each side. That means those two sides are equal, and that's what causes these two bottom measures to be equal to each other. So they tell us that B is equal to C. That's one of the things they tell us. They give us the equations for each of these variables. We've highlighted them over here, or each of these angles, I should say. And then we're going to be able to bring some information to the table. So, and this is something that was talked about in Math 60 earlier in the book. We're going to bring our own formula here, BYOF, what we know about triangles, and that is that the three angles, when added up together, equal 180 degrees. A plus B plus C equals 180 degrees. Now now that we've brought something to the problem, kind of really understand what we're given and what we know about the situation, let's look at our setup. And again, we're in 5.4. It says to use systems of equations, so we can expect to set up two equations to match the situation here. So one of them represents the fact that we've got A, B, and C added together equals 180. So we start with that fact. A plus B plus C equals 180, which in this case, A is 4x plus 2y plus, in fact, maybe I'll try some different colors here to maybe make this really, really clear. And we'll use the dark blue to add these together. Okay. So our A value is the 4x plus 2y. Our B measurement is 9y minus 2. Our C measurement is the 10x plus 10. And that all together equals the 180. So here's your A, your B, and your C. So that we're just setting up that first equation here. So we'll even just label that. This is our attempt to create the first equation. Now we can go ahead and simplify and add the x's together. 4x plus 10x is going to be 14x. Add the y's together, 2y plus 9y, that's going to be 11y. And then we've got a minus 2 plus 10, that's going to be a plus 8. I'm going to go ahead and subtract that from both sides and get me to the 172. So what I did was I combined like terms to get my x's, my y's. I have constants on this side. I really want to get them over here. Negative 2 plus 10 is 8. I subtracted 8 from both sides, and that's how I got the 172. Okay. Equation 2 has to do with what they tell us, the fact that angle B equals angle C. So that's where we have B equals C. So angle B we know to be 9y minus 2. Angle C is 10x plus 10. And now I'm going to rearrange that as well and get all the x's and y's on the left side, numbers on the right. So I'm going to subtract 10x from both sides. I get negative 10x plus 9y. I'm going to add 2 to both sides. So I get negative 10x plus 9y equals a positive 12. Add the 2, subtract the 10x, get that rearranged. And now I have my first and second equations, my 14x plus 11y equals 172, and my negative 10x plus 9y equals 12. So I'm going to go ahead and write those in one set. So I have 14x plus 11y equals 172, and I have negative 10x plus 9y equals 12. I have my choice. I can graph, I can use substitution, I can use the addition method. I'm looking ahead, and if I wanted to use graphing, I'm not guaranteed nice numbers here. So I think I will move on to my other two choices. Substitution would mean I'd have to solve either of these equations for y or x and then resubstitute back in, and I'm seeing that there's a potential for lots of big ugly fractions. So for me that says, you know, error alert. I could make some mistakes doing that. So I think I'll stick with my addition method. So now I'm looking to see what I could multiply top and bottom by to get one pair of the coefficients, either the x or the y, to be equal but opposite signs. I'm kind of leaning toward the x just because one is already negative and one is positive. So then I could just multiply, either multiply by the least common denominator, or you can just multiply by each other. Either one, it doesn't matter. I'm going to go ahead and just kind of make it simple on myself. You could, let's see, what would that least common denominator be? 2 and 7, 2 and 5. You could multiply by, well, actually we'll just have to multiply by what's there. So if we multiply by 5 up here, that'll give me 70. And if we multiply by 7 down here, that'll give me negative 70. And if you can't see that that would work for you, you can also just use the numbers that are there. So I could just use 10 and multiply on the top because that's what's already on the bottom. And I could use 14 on the bottom because that's what's already on the top. So I'll just do that method. If you want to talk about or work with how to do smaller numbers, feel free and I can show you how to do that in class. Okay, so as I multiply by 10, the top equation becomes 140x plus 110y is equal to 1720. And the bottom equation becomes negative 140x, which again was our goal, to make matching but opposite signs of coefficients, plus 126x as I multiply each piece by 14, equal to 168. And then I'm going to use the addition method to add these together. And when I do, the x's fall out. That was expected. The 110y plus the 126y gives you 236y. The 1720 plus 168 gives you 1,888. And then you divide both sides by 236, and you actually get a pretty nice number. Y is equal to 8. From there, we need to find our x values. So we found our y value. It's 8. Which actually means we could plug it into here and we'd get our b. So 9 times 8 minus 2, 72 minus 2, that's going to be 70. So we found our answer for b at 70. But we need x before we can figure out the other pieces here. So we can take any of the equations here. I'm going to go ahead and get back to this one that had b equal to c. So 9y minus 2 is equal to 10x plus 10. That seems fairly easy to plug into here. So I'm going to go ahead and take that one. 9y, bring it down here. 9y minus 2 equals 10x plus 10. I left a workspace for my y, so I could plug it in right there. Instead of y, putting 8. And that's going to give me 72 minus 2 is equal to 10x plus 10. That gives me 70 is equal to 10x plus 10. Subtract 10 from both sides, I get 60 equals 10x. And then that gives me x is equal to 6. And I'm slowly encroaching on the other problem here, so I'm glad we came up with that when we did. So our x value is now 6. And that means we can plug our x into our x and y into our two leftover equations to come up with a and c. So we'll start at c. 10 times the 6, the x, plus 10, that's going to be 60, plus 10, that's also going to be 70, which makes sense because they told us that b and c would be equal. So our algebra is matching what the description was, so that's a good sign. And then finally, coming up with a, we're going to put in our x value and our y value into this equation. Again, our x value was 6, 4 times 6, plus 2 times our y value. Our y value was 8, 2 times 8, and that gives you 24 plus 16, or 40. And what we know about the triangle, that these three should add up to 180. 40 plus 70 plus 70. Two 70s give you 140, plus another 40 is 180. So that part makes sense to what we know. It also checks in the situation where b and c are equal to each other. So that's a good way to check, is going back to this original description of the situation.